The title of this presentation is Sewage and Wastewater Treatments. This presentation is aimed at providing the student with the basic ideas discussed during the normal classroom lectures. It is expected that students will utilize this video in order to grasp the ideas discussed during the classroom lectures. Now, when we mention water, safe or wholesome water can be defined as a water that is free from pathogenic agents, a water that is free from harmful chemical substances, a water that has pleasant to taste and usable for domestic purpose. Such type of water is called safe and wholesome water. Now, generally, when water is obtained from uncontaminated reservoirs, maybe from clear mountain streams or from deep wells, it requires minimal treatment to make it safe to drink. However, in our contemporary society, many cities obtain their water from badly polluted sources, such as rivers that have received municipal and industrial waste upstream. Hence, city or municipal water requires purification before being used for domestic purpose. Generally, there are 4 major steps used in municipal water purification. However, it should be noted that the water treatment is not intended to produce sterile water, but rather a potable water, which is a water that is considered safe for drinking. That is to say, a water in which the levels of microorganisms or chemicals in the water are low enough that they are not considered a health problem. They are not of health concern. Now let's look at the stages for the water treatment. The first stage of water treatment, as can be seen in this outline, is the sedimentation process. So sedimentation is served as the first stage of the water treatment. Now, this stage generally involves physical removal of heavy particles in the water. During the sedimentation process, generally water is pumped into holding tanks where particulate materials such as sand, silt, and organic materials settle at the bottom as in form of sediment, leaving the partially clarified water containing suspended materials, which are called colloids, that are too light to settle down. So the suspended water will contain the semi-clarified water will contain the suspended material, while all the heavy materials will settle down. This process is called sedimentation and is the first step in water purification process. Now, the second stage of water purification involves flocculation. Flocculation, which is the second stage, involves removal of the colloidal materials, and some microorganisms from the water. That is the suspended materials that are left during the sedimentation process. So the colloidal materials and microorganisms attached to them are removed. So the partially clarified water is pumped into the in this process. Partially clarified water from sedimentation is pumped into secondary tank for flocculation. Now, during the flocculation process, usually certain chemicals are added, such as alum or aluminium potassium sulfate. Aluminium potassium sulfate, which when added to the water, it helps to join the suspended particles and microorganisms to form large aggregates, which are called flocks. Now, this large aggregate will now settle down at the bottom of the tank. So that is to say, this flocculation process involves mixing the water with alum or sedimenting chemical to make the suspended materials in the water to settle down, so that the water will now become clear. Now, the next step in the water purification is the filtration stage. Now, in the filtration stage, in this stage, generally involve removal of microorganisms, and some of the colloids that were not removed during the flocculation process. So microorganisms that were not removed during the colloidal process are removed. Therefore, large number of microbes are reduced by about 90% during this process. Now, this particular process is achieved in several ways. One of the methods used involves the use of sand and other materials to which microbes will adhere to form biofilm that trap and remove other microorganisms. So a kind of simple sand filter is used in this particular stage. The second stage that is also used is slow sand filters. Slow sand filters are slightly advanced than the common sand filters. They are generally composed of about 1 meter layer of fine sand or diatomaceous earth, and they are commonly used in smaller cities or towns to process water. These slow sand filters are capable of processing about 3 million gallons of water per day. They can filter up to 3 million gallons per day. However, in the case of larger cities, rapid sand filters are used. These rapid sand filters are larger than the slow sand filters, and they contain larger particles and gravels that can be able to process up to about 200 million gallons per day. Now, both types of filters are generally clean through back flushing process of water. In addition, we have two other filtration methods, which are the membrane filtration. In membrane filtration, membrane filter is used, which has a pore size of very small pore size of about 0.2 micrometer. And then the filtration then the filtration is achieved through pressure by means of pressure. Now the second one is activated charcoal. Activated charcoal provides added benefit of removing some organic chemicals from the water in addition to the normal filtration. At this stage, the water becomes clear, free from any suspended materials. However, it's not completely free from pathogenic microorganisms. Therefore, the next step is used, which is the disinfection stage. During the disinfection stage, ozone, UV light, chlorinations are used to kill microorganisms prior to the release of the water for public consumptions. In most cases, chlorine gas is being used. This gas is an oxidizing agent. It's an oxidizing agent that kill microorganisms through denaturation process. However, in some cities, as I said, UV is also used, which also kill microorganisms through mutation and so on. It should be noted that chlorination and UV does not kill some of the microorganisms. It does not kill all the microorganisms. Example, most viruses, as discussed earlier, are not inactivated by chlorine, and some bacterial endospores, protozoan cysts, all these are generally unaffected by chemical treatment. So these can only be removed through mechanical filtration of the viruses or the endospores. Now these are the steps in water purification. Now let's look at the next purification process, which is for wastewater or sewage purification process. Now sewage or wastewater is generally defined as any water that leaves homes or businesses after being used for washing, flushing toilets, and so on. Some municipalities also include industrial water and rainwater as a type of wastewater. In general, wastewater contains a variety of contaminants, which include suspended solids, biodegradable and non-biodegradable organic and inorganic compounds, toxic metals, pathogenic microorganisms, and so on. Now, That is why the objective of wastewater treatment is to reduce these contaminants to acceptable limits. Uh, so in this process, a key concept used in processing of wastewater is to reduce what is called the BOD. BOD stands for biological oxygen demand. Biological oxygen demand is the amount of oxygen required by aerobic bacteria to fully metabolize organic waste in water. Therefore, reducing the biological oxygen demand implies reducing the available dissolved oxygen in the water, and hence it will limit the growth of microorganisms. Today, people living in larger towns and cities usually they have a kind of connected municipal sewer system or collection of pipes that collect wastewater to deliver them into sewage for treatment, into various sewage treatment plants for treatment purposes. In countries that are less developed, open gutters are used to convey sewage to treatment areas. In general, traditional or sewage treatment consists of 4 major steps as follows. We have the primary treatment. Primary sewage treatment generally involve skimming of suspended solids from water. So in these steps, wastewater is pumped into a settling tank where lightweight solids, grease, and floating particles are skimmed off, and then heavier materials will now settle down at the bottom. So this one is a kind of a modified sedimentation method we notice in purification of a municipal water purification process. In sedimentation, the larger particle settles at the bottom to form sludge, while the heavier materials remain floating on the water. But in this type of treatment, the lighter materials are skimmed off, are removed, and the heavier materials will settle at the bottom. So this treatment stage is called the primary treatment. And in this type of treatment, about 40 to 60% of suspended solid are removed from the sewage by this settling method, and flocculating chemicals that increase the removal of solids are sometimes added at this stage so that more suspended solid will settle down at the bottom to form flocks. The sludge that is formed is removed, and then the partially clarified water is further treated in the next treatment stage. So during the primary treatment, about 25 to 35% of the BOD in the water is removed. Now the next step of the treatment is the secondary treatment. Secondary treatment is generally a biological treatment. It involves reduction of the BOD by about 25 to 25% of the original. So in this type of treatment, most pathogenic microorganisms are removed from the water. The water is aerated to facilitate the growth of aerobic microorganisms that oxidize, dissolve organic chemicals to carbon dioxide and water. So the aeration takes care of most of the pathogenic microorganisms, because most of the pathogenic microorganisms are facultative anaerobes. So by aeration, by aerating the system, most of the pathogenic microorganisms will be killed in this process. And then we have advanced secondary treatment, in which a kind of activated sludge system is used, in which aerated water is seeded with primary sludge containing high concentration of metabolizing bacteria. The only difference between this activated sludge system and the normal sludge system is that aerobic microorganisms are prepared. The culture of aerobic microorganisms are grown, and then they are seeded in the primary sludge. Then after that, aerated water will now be pumped into the sludge. So in this process helps to remove most of the pathogenic microorganisms, because now we have more aerobic microorganisms that will take care of some biodegradable materials in the water, and aeration that takes care of pathogenic microorganisms. So after this, any remaining solid materials that settle at the bottom will be added to the sludge that is coming from the primary treatment. In some communities, the secondary treatment is accomplished using trickle filter system. Trickle filter system is just similar to slow sand filters used in water purification process, but is generally less effective in removing BOD than the activated sludge system. So after all this, after the degradation of the suspended particles, settling down of the sludge will be pumped together with the primary sludge to anaerobic holding tanks, where it will be further treated. Now, the next step therefore involve the sludge treatment of the sludge. The pre-water collected will be can be released, while the sludge, as we said, collected from the primary and secondary treatment will be sent to anaerobic tank for treatment. Now, during this particular treatment or sludge treatment, there are stages. First, there is anaerobic digestion, anaerobic breaking down of organic particles. So anaerobic microorganisms are used to ferment organic materials to produce carbon dioxide and organic acid. In the second stage, microbes The aerobic microbes metabolize this organic acid into carbon dioxide and hydrogen gas. So they metabolize them into carbon dioxide and hydrogen gas, which will diffuse out. And finally, the carbon dioxide are converted to methane gas by methane producing bacteria. So they are converted to biogas. So any leftover of the sludge is then dried and then is used for landfill or is used as fertilizer because it contained organic matter, a lot of organic matter. So it is used as fertilizer. Now, the next treatment after the sludge treatment is the final treatment of the clear water that comes from the primary and collected from the primary and secondary treatment process. And this treatment is called the chemical treatment method. During the chemical treatment method, water from the secondary treatment is disinfected, usually using bichlorination method, after which it can be released into rivers or oceans and recycled for drinking, or in some cities, the water can be used to spray for spray irrigation of crops and maybe highway vegetations. Some communities remove the nitrate, phosphate, and any remaining BOD or microorganism from the water by passing it by passing it over pine sand filters or activated charcoal filters. So the nitrate will be converted to ammonia and discharged into the air. And this process roughly removes 50% of the nitrogen content, whereas phosphorus is precipitated using lime or alum, which removes 70% of the phosphorus. So this such type of treatment is generally referred to as the tertiary treatment. So in this tertiary treatment, the water is made, it can be recycled for drinking after the additional treatment received by the water. Now we have the next type of treatment is called the industrial sewage treatment. The previous one is the municipal sewage treatment. This one is the industrial sewage treatment. Now, generally, industrial sewage treatment is similar to the municipal waste water treatment, except that in industries, larger particles or materials are first skimmed. They are first larger materials here are first skimmed and then grinded before the sedimentation process here. So before the sedimentation process, as can be seen in step 2 here, step 1 involves skimming and grinding of the larger particles or materials. And then in addition, when you look at it, most of the industries use activated sludge system, which we said is the most effective compared to the slow sand filter techniques. So they use activated sludge system for the treatment of the waste during the secondary treatment processes. which involves the use of microorganisms to digest the organic materials. So after the uh, after the after the primary treatment, the secondary treatment using the activated sludge or the trickle filter system. The next one is the sludge treatment, uh, which we said is just like the previous sewage treatment, domestic sewage treatment. We already explained. It involves both anaerobic and aerobic digestion of the sludge, and finally the leftover will be used for a landfill or as fertilizer. And of course, the last stage involves the chemical treatment method or disinfection by chlorination before the water is released into nearby river for recycling. So uh, this is in short the industrial treatment process. So the other treatment processes we may need to talk about include the agricultural and rural waste treatment, which involves the use of septic tanks, cesspools, and oxidation lagoons. So in the generally houses in the rural areas in developed countries, houses are connected to sewer lines, and then the sewer lines collect various waste from individual houses, and then the sewer system convey the sewage into a closed tank, which is called the septic tank. In this septic tank is essentially uh, an equivalent of the primary sewage treatment, where the settling method will take place and so on. Now, sewage from the houses enters the sealed septic tank. The solid settles at the bottom. The liquid will now flow from the top of the tank into an underground leach field. So the septic tank is designed such that uh, at the top, the sewage is added, and the tank has a kind of two compartment. So as the sewage is being added, flux settle down at the bottom, while the water will now move into the next column of the tank. Now from the next column of the tank, the water will now be released into field for irrigation purposes. So the sludge in the tank and organic chemicals in the water are digested by microorganisms, just like in the secondary treatment. So in essence, septic tank serve is a kind of closed system that provide complete waste treatment. All the stages: the primary treatment, the secondary treatment. However, uh, it does not remove some of the pathogenic micro organisms compared to the other system. Now, apart from septic tanks, cesspools are also used. The cesspools are generally similar to septic tanks, except that they are not sealed. Unlike the septic tanks are sealed, while the cesspools, as the name implies, pools, They are not sealed, they are open. So as the waste enters the system, it has a system of, it is made up of a system of porous concrete rings buried underground. So when the water enters, the water is released into the surrounding soil, while the porous the pores retain the larger particles, which are being digested by anaerobic microorganisms. So it's just similar to the septic tank, only that this one is an open system. Now we have the agricultural waste treatment. In agricultural waste treatment, this usually is carried out in rural areas in which farmers use what is called, they build what is called oxidation lagoon. An oxidation lagoon is a kind of pond that is built for treatment of animal waste from livestock. Now, it generally serve like a secondary waste treatment, because both the floating materials that are removed during primary treatment and the larger particles all are in the same lagoon, where decomposition of microorganisms take place. So the sludge in the tank and organic chemicals in the water are digested by microorganisms. So after digestion by the microorganisms, eventually the microbes die and clarified water is released into rivers or streams. Microbes usually die when the nutrient is exhausted. So finally, the clarified water is released into rivers or streams. However, one problem with oxidation lagoon is that they are open, which can be dangerous if there is flooding. When there is flooding, they can easily spread uh, untreated animal waste and pathogenic microorganisms. So in essence, these are the major uh, uh, water and sewage treatment processes.